All right, so we want to be able to predict the direction in which a spontaneous reaction is going to occur when it comes to electrochemistry. So we know we have this kind of uh, table right here that gives us these standard cell potentials, and so we can use this to predict spontaneity. So one thing that you're going to notice about this table is that it's always written as reduction. You can see everything here on the left side is from left to right is being reduced. That's not necessarily the way it's going to happen in the reaction. It's just by convention, we always write it as being reduced. So tables, always written as reduction. So remember that electrons are negative, and so they want to go to the more positive potential. So the more positive potential, that one will gain electrons and be reduced, and the more negative potential will lose electrons and be oxidized. So for example, if I showed you nickel 2 plus, so we're going to construct a cell out of nickel and manganese 2 plus. So I've written it the same way as in this table, in both in reduction, right? But they can't both be being reduced. One of them needs to be reduced. One of them needs to be oxidized. So let's take a look at our table and let's find nickel 2 plus going to nickel solid. And so that's right here. You can see we have nickel 2 plus gaining 2 electrons to form solid nickel, and that happens at negative 0.23 volts. And then we have this manganese. Let's go ahead and find that in this table. And so you can see that's down here. You see manganese being reduced, and it happens at negative 1.18 volts. So the question here is, what will the overall reaction be? Or which one's the cathode, which one's the anode, all kinds of different questions. So there's multiple different ways that you can kind of think through this problem. One way is to remember that its E cell is E cathode minus E anode. And remember, for a spontaneous process, this must be positive. So one way you could do it is you could plug the numbers into here, plug them in one way, plug them in the other way. Whichever one gives you the most positive number or the biggest positive number, that's the correct answer. The other way I like, and the way I like to think about it, is remember that electrons are negative. So they're going to go from the more negative number to the more positive number. Negative 1.18 versus negative 0.23. The negative 1.18 is more negative, and so the electron is going to flow from the more negative number to the more positive number. And if we think about what that means, this manganese reaction is actually going to be reversed, right? It's losing electrons, and losing electrons is oxidation, and so oxidation occurs at the anode. So we're going to plug this number into the anode, and then the nickel is going to gain electrons, so it's being reduced. That's the cathode. So that goes over here, and then you just plug in the numbers. Negative 0.23 minus a negative 1.18. And then if you go ahead and do the math there, .95 volts, right? Positive number, a negative minus, or two negatives cancel each other out to a positive, and then you want to think about what the overall reaction is. So think about which one's the anode, which one's the cathode. Manganese is the anode, and so it's going to be being oxidized. Nickel is on the cathode side, so it's going to be being reduced. And there's your overall spontaneous reaction.